So if you can see my screen, you should see 14.
Yes, I can see that. Perfect.
All right, in the figure to the right, two boxes of masses 2m and 5m are in contact with each other on a frictionless surface. A force F is applied to 2m. Answers to the following question should be terms of F and M. What is the acceleration of the more massive box? Okay, what is the force causing the acceleration of the more massive box? The net force on 5m. What is the force exerted on the smaller box by the larger box? What is the net force in the smaller box? Okay. The question here, I need to quickly confirm. Just I don't want to get off too far in the wrong direction if I'm not right, but I want to give me just. I just want to check on making sure I remember how this goes. Sorry, I'm just I'm reviewing some stuff here. I don't want to get this wrong for you.
All good. No worries.
Um, Forty 41 here. D and D. Okay. What is the force causing acceleration? Okay. All right. Okay. So the acceleration of the more massive box. Okay. The we kind of have to look at the whole thing for the moment. So there's a force, and really you treat these as being together for the moment. So what is their combined mass here in terms of m?
Their combined mass
Yeah,
should be like 7m, right?
2m plus 5m is 7m. Great.
Yeah.
And we know that sum of the forces equals mass times acceleration. So
True.
quite simply, we can say, boy, this happened earlier where I can't scroll. This is frustrating. Let me insert space. Did that help? Sorry, I'm not able to scroll, so I'm trying to get this thing to, there it is. So the force here, force equals ma. So acceleration is F over m. Is that okay?
That's okay.
What is the mass? Well, it's 7m. So the acceleration of the more massive box is the same as the acceleration of the less massive box because they're moving together.
Okay.
So answer to A is F over 7m.
So F over 7m. Okay.
Yeah.
All
Now,
right. Now we
where
are
it
on the
gets,
B.
yeah, what is the force causing the acceleration of the more massive box? The net force on 5m. So what's happening is that block, the 2m block, is pushing on the 5m block, and the 5m block is pushing back on the 2m block.
Okay. That's true.
So it's a ratio thing here. Like the we're talking about the more massive box here. The more massive box is 5 of the 7. Do you agree with that?
I do.
Okay. So the part B here is that it's 5 of the 7 F. Like whatever the force is, this bigger blocks, because its mass is 5/7 of the like group, it becomes 5/7 of the whole thing.
All right.
And then the smaller one, well, it's 2/7.
Mm-hmm.
Force becomes 2/7 because it's 2 out of 7.
Mm-hmm.
So the small, what is the force exerted on the smaller box by the larger box? So it's it's pushing back. I apologize. This area of physics isn't my my favorite.
Expertise.
It's yeah. It's I feeling like I'm struggling a little bit here. So but we're okay so far. We're at what is the force exerted by the smaller box by the large box? We have that. It's oh, I'm sorry. I put this. I'm misreading this. So the force causing acceleration of the more massive box is that I put this in the wrong place. The force exerted on the smaller box by the larger box. So whatever is causing the larger box to accelerate, okay, which is this force right here,
Mm-hmm.
that's the force that's being applied backwards to the smaller box.
Oh. All right.
So, but it's in the other direction. So C ends up being negative 5 over 7F because it's going in the other direction.
Negative 5 over 7f. All right. What about B though? So the answer is 5/7, right?
5/7 for B. C is asking what's the opposite, like if you it's kind of like if you just isolated the 5m box. The acceleration of the 5m box is 5/7 F. And the acceleration on the little box is 2/7 F. But now when it's asking for the force exerted on the smaller box by the larger box, it's whatever force is causing acceleration of the larger box.
All right. All right. D. What is the net force on the smaller box?
So the net force on the smaller box is the 2/7 F because the net force is what causes the acceleration.
Mhm.
So the net force, it's basically asking A and D are related. Like, I'm sorry, B, it's wrong. B and D are related because whatever force causes the acceleration of the larger box, which is 5/7 F, D is the 2/7 F because that's the part that it contributes to the acceleration. The net force just means what forces are
You on it?
are causing the acceleration.
Okay. On to E. Show all the forces acting on each blocks below. So it's on these diagrams for
Yeah,
2M and
yeah,
5M.
we gotta get those on there. So it's let's do it this way. So let's look at the one on the left there. It has mg down,
Has MG down? Yes.
normal
Does it have
force up,
normal force? All right.
normal force up. Okay, it obviously has the force F acting on it.
Mm-hmm.
Okay, but we can resolve that into, well, there's a force acting on it from the 5M box.
All right.
So it's the one that's pushing back on it, which is the -5/7 F. So it's not really this F. It's the result of
Makes sense. Do we use the 2/7 for this next one for 5M?
so for the one on the right, you have mg down and up, and then it's the net force. It's really only the net force. It's the 5/7 F on it.
All right.
Actually, so this is where I'm not sure. Like you can say this, or you can say it's 2/7 F to the right. I don't know what they want for sure. Um, oh no, is there another part to this? Bet there is. Yep, do everything now with friction. Okay, I'm laughing because it's like we just did a. It's like, oh, just redo the problem as if there's friction. Okay. Um, all right, so I guess I'll run through that now.
All righty. Answer part A through D's. So do I put like? Never mind.
Well, we got to start with A again. So A is essentially asking, A is the same question for what is the acceleration of the more massive box? And but now though we have friction to deal with. Okay, so it's not as straightforward as before. So the forces, if we think about all the forces acting on the system now, we're going to do part A, because the part A is this sort of this system here.
Mm-hmm.
We have F, we have force of friction, or Fk, and then it's going to the right. So sum of the forces equals mass times acceleration. We have F minus force of friction equals ma, but m is really 7m because it's 2m plus 5m. So acceleration is equal to, well, actually, let me not jump to that step. Um, just get that in here. So the F minus force of friction equals 7m times a. So acceleration is F minus force of friction over 7m.
Let me get this all down first.
There's a bit more here, so we're not quite done, because the force of friction is equal to mu k n, and we know that n is equal to mg in this problem, but m is really 7m. So we know that n is equal to 7m times g. So the force of friction is mu k. Instead of N, it's going to be 7m times g. And all of that has to go over here. So the acceleration is really force minus 7 mu k m g over 7m.
Oh man, that's a lot.
It is. As soon as you add friction, it's way more complicated, and it's just whatever. It's um, okay. So part B is the what does part B say? Part B says the force causing acceleration of the more massive box. So like without doing the physics, it's gonna be 5/7 of something because
Mhm.
that's its mass. And that's where it's 5/7 of something, just like before. Before it was just F, but what's the difference now in this problem? It's not F anymore, it's the force of friction.
All right.
So this whole yeah, I mean boy, I'm trying to okay, so we'll come back to this. So it's sum of the forces in the x direction equals mass times acceleration. But if you're just focusing on the large box, m is 5m.
Okay.
Do you agree with that?
I do.
So we got the force, the net force, which is what this is. So we can just call it force net on the box. It's 5m. Well, what's the acceleration? Well, we just had it up here. It's this F minus 7 mu k mg over 7m.
All
Like
right.
like we literally just grab that, and this m cancels with this m, and if you just bring the 7 out, it becomes 5/7 F minus 7 mu k mg. There's really this part of this problem that's understanding that the net force, you don't have to actually like write it. You just have to say the net force is, or like you have to just be okay with like, I don't know what they are, but I know the net on the net of the forces is this, which is what we wrote here. Because we're actually gonna do the same thing for D. I know C is next, but D is it's, if you remember from the previous problem, D is it was 2/7 of something.
Mhm.
Well, the net force on that small block, which we're going to call the force net, equals mass times acceleration. Well, the mass is really 2m, and the acceleration is the same as in the previous part of the problem. It's the F minus 7 mu k mg all over 7m. And the m's cancel again. So you end up getting 2/7 F minus 7 mu k mg. I guess we could have done part C next, because it's just an equal and opposite thing. Um, C is the answer to B, which is, let me scroll up here. This is the answer to part B. The answer to C is the equal and opposite. So it's just a negative sign in front.
So negative 5/7.
Yep. It's just going the other direction.
Sounds good.
And that's it, because it doesn't ask for part E, thankfully.
Can you scroll down to D real fast?
Yes. Sorry.
All good. Thank you. Oh, on to number 15.
Yeah. Gosh, they really like these are college level physics problems, mechanics problems, and it's just. I mean, I remember. I don't know. It seemed like a couple of weeks ago we were just talking about simple one dimensional motion, and now you're doing pretty complicated force problems. Okay, this arrangement is being pulled across the floor. The coefficient of kinetic friction between the larger block and the floor is zero point 0.5. The coefficient of static friction between the two blocks, there's a coefficient of static friction between them. Um, and then, so we got there. Note that the weight, not the mass of each block is given. Okay. What do they want us to find? Is there another page to this? I mean, I can sort of guess what they want, but
No, it doesn't. It doesn't give the what it
there. I
wants.
mean, there is more to this. There's got to be like part A and B. Like part A is like what's the acceleration of the blocks before it begins to slide. Um,
Wait, check my where I got this from. No, it doesn't give a question at all.
well, I found this problem online, so we can definitely do it. I mean, unless you want to do something else, but I would recommend we do it.
It's fine. Let's do it.
It asks, what is the maximum acceleration? Yeah. So it asks for so like at some point, this is kind of like your car, something in your car seat. At some point, the top block is gonna slide off.
Okay.
Is that believable? Like imagine you're pulling your sister in a sled and you pull really hard. Well, she's gonna fall back.
Mhm.
All right. So we have you have to look at the free body diagram of the things here. So all right, the sorry, I'm just looking at this. So um, the top block here has a force down. That's the 30 newtons. It also has a normal force up, and to the right is a frictional force or force of friction, static friction because it's not moving because it's moving forward
All right.
of the blocks before the top block. Okay, being set up. All right. So the sum of the forces equals mass times acceleration. So we know that the only force is this Fs, and this equals mass times acceleration. Now
True.
Fs is equal to mu s times n, and the normal force must equal the mg down. Normal force must equal mg down. So this is mu s mg equals ma. And the acceleration just is what they're asking for. The m's cancel, so the acceleration is equal to mu s times g, which is point. Did they give that to you? Yeah, 0.75 times 9.8. So that's whatever it is. It's like 7.4 meters per second squared.
Sounds good.
Part
So I
B.
think
There's actually part B if you want to keep going on this.
actually I think it's fine. I think
Okay.
we can go over the math now.
Okay.
I'm just looking for my book right now.
All right.
I'll send you photos when I find it. All right, found the book. I'm gonna send you the pictures now.
Okay. Sounds good.
We probably don't have enough time to do all of it, so I'm just gonna get a good start on it, so I get an
Okay.
idea what to do. All right, it should be just one page. No, there's no way. There it is.
Okay. I see some pictures have come in. Let me know where you want to start. Looks like 5.1. If you were talking, Jack, I couldn't hear you. Just need you to unmute.
That was why I got booted
Jack.
from it for no reason.
Yeah, sorry about that. Where do you want to start here? 5.1,
Yes. Number 10, please.
number 10. Okay. The way you do 10, 11, and 12 here for 1-to-1 is there's what's called a horizontal line test. I know you're familiar with the vertical line test for functions. Horizontal line test is for whether it's 1-to-1. So you draw a horizontal line, horizontal line, horizontal line. If it hits it one time, it is 1-to-1.
Mhm.
So these are both 1-to-1. If it hits it two times, like this or more, although I don't know if it can hit it. Yeah, I guess it could hit it more. It's not 1-to-1. So that is one way you can do it based on the graph itself.
Mhm.
So the answer here is yes, yes, and no.
Yeah. All right. Now on to 13. Should be. What is 13?
13 is the same set of instructions. Let me snip them in, and then we'll do the same thing here with this. So I'll do 14 first, 15. This one, it hits it everywhere. So this
Uh-huh.
one hits it one time, and this is I don't know, infinite times, we'll say. So the answer is no, it's not 1-to-1. Yes, and yes.
Perfect. All right. On to number 37, please.
Use the definition of the inverse to show analytically that f and g are inverses. That's quite a bit to take in. So the definition of the inverse means that f bubble g produces x and g bubble f produces x. And if you don't know what the bubble is, that's what we're about to do. It's composition.
All right.
So for this first one, it's often written like this: f of g of x, which means to take this and put it in for x.
Oh,
So we'll do that
okay.
here. So it's 3 times x plus 7 over 3 minus 7, and then you simplify.
So multiply it all out and divide by 3.
Yeah, you can actually cancel the 3's. So you get x plus 7 minus 7, and you just get x, which we expect.
Yeah.
That's only part 1 of 2.
Yeah. So
So
now we got to find the other one.
g of f of x, which this time means to take whatever f of x is, which is 3x minus 7, and put it in for x. So it's 3x minus 7 in for x plus 7 over 3. And then we simplify this. So the numerator becomes just 3x over 3, which becomes x, and that's
So they are
part,
inverses.
or it's part 2 of 2. They both have to work. If for some reason you do one and it works, you can't just say, oh, they must both work, because that will be on your midterm final. That doesn't work. Okay, what's the
All right.
next one here to look at?
Number 38 and number 39.
Okay. Why don't you try 38 on your own, because it's basically the same thing, and let me know if you do not get that they are inverses, because they are. Like, it should work out.
All right. F of g of x. So it's like They are inverses. I got it.
Yep,
And
that's
now
correct.
on to number 39. Same thing. Oh wait, this is just different.
It's a little different, but they do work out. I'm gonna snip it and show, but like when it tells you to show something, that means that they are. They're not saying if they are. They're saying that they are. So let's go f of g of x, which means you're taking the cube root of x minus 4 cubed plus 4. The cube undoes the cube root, so this becomes x minus 4 plus 4, which becomes just x. Part 1 of 2 done. Now we're going to do g of f of x, which means to go the other way. Take the x cubed plus 4 and put it in for the other one. So it's the cube root of x cubed plus 4, minus 4, which becomes the cube root of x cubed, which becomes just x. So it does work out.
All right. Let's go to number 43.
Okay, well, the answer's already there, if we believe it. All right, so if determine whether it's 1-to-1. So the horizontal line test means that you have the same y value for two different x values. Okay, so what you're looking for is, and you don't want to plot these, you want to look for duplication in y. Do you see any duplicates in y?
No.
So it is 1-to-1.
So 3 is a guess.
Yeah.
Number 44.
44 is for the same reason. 45 is the next one to look at if
So you're looking for duplicates in the Y? Is that what you're looking for?
yeah, and then we'll talk about how that, like, that's not a guarantee, but that's what we're looking for. So let's look at 45.
45 is no.
So the reason 45 is not 1-to-1, there are these duplicates in the y value. Okay, so now the next check is are these different x's?
Yeah, they're all different x's.
So then it is. But if they were the same x, it would just be a dupe. Like if this was 1, 5 over here on the right, it's just the same point. That's okay. But because they're different x's, that means it's no.
Mm-hmm. Makes sense.
Because a horizontal line would go through both of those points. What's next?
Number 55.
Okay. For each function, write an equation the inverse, then graph them on the same axis. Okay. All right. So the inverse is a recipe. It's a sequence of steps that you will always do for these. So I'll leave the graphing up to you. You'll have two things to graph when you're done. But the first thing you do to find the inverse is you switch x and y. And what that means is wherever there's a y, you put an x. Wherever there's an x, you put a y. So we have x equals 3y minus 4. Step 2 is to solve for y.
All right. Y equals x plus 4 divided by 3.
Okay, and then I don't know if it's really a step, but you say y is really f inverse of x. So you have your inverse function. F inverse of x is x plus 4 over 3.
Oh, okay.
Right. The mechanics of this are really important. You can and you can go to Desmos if you want to graph them, and you can get whatever you get. But we should do some more questions for this. It says to give the domain and range. if the function is not one-to-one adjacent. So, um, boy, there's a lot to this. So the domain of the original is minus infinity to infinity, and the range is also minus infinity to infinity, because it's a straight line.
True.
Now this mapping, we're not out of time, but this mapping is really important. F and F inverse, and then you have your domain and your range here. So let's just say I'm going to call this A up here and this B. So your domain of F is A, your range of F is B. The domain of F inverse is B, and the range of F inverse is A. There's this relationship
Oh, I think I remember this.
that you have to know. For lines, it's not that interesting. It does matter for other problems that are kind of here. I don't know how many you were doing, but there's some here where this could be an issue. What's the next problem you need to do for homework?
Number 57.
Okay, let's do 57 because it's got a few things in it that are kind of dicey, I guess. No, the 57 is not a problem. Boy, it's okay. All right. So the domain of this function is minus infinity to infinity, and the range you'll find is also minus infinity to infinity.
All right.
Which means that the if this is F inverse, this comes down here, and this goes up here. Now, I just told you that we can see it graphically, but let's review the steps for finding the inverse. So the first is to switch X and Y, meaning wherever you see a Y, you put an X. Wherever you see an X, you put a Y. Step two.
All right.
Step two is to solve for Y. This is where hopefully there's some comfort with that. It's not meant to be difficult, but you often have to undo exponents or roots. In this case, y equals the cube root of x minus 1. And then step 3, I don't even know if it's a step, but you say y is really f inverse of x. So you write it as f inverse of x equals the cube root of x minus 1. So if we were to graph these, x cubed plus 1 looks something like this.
Mm-hmm.
And cube root x minus 1 looks something like this. Okay.
Okay.
And you'll see that there's symmetry across this line y equals x. Like there's a nice, I don't know, mirroring, so to speak. I don't know if you see that or not. Like this mirrors this part mirrors this part, and so on. If that's not clear, we would have to do some more explanation. So, do you have to do 59?
No, number 67.
67. Okay. I'm gonna run through 67, and we're gonna have to stop after this one. This is actually an exam quality question. Because there's some extra steps. This guy used to help with the dental admissions test. He would regularly just not know how to do these problems. Okay, so y is really f of x. That's kind of like step 0. If you don't have f of x, or if you don't have y, we call it f of x. The next step is to replace x for y for x.
All right. True.
So now you gotta multiply both sides by y plus 1. So this becomes x times y plus 1 equals 4y, because the y plus 1 cancels over here on the right.
Mm-hmm.
You're going to distribute this x. Remember, we're trying to solve for y. So you get xy plus x equals 4y. you have to get the y's on both sides of the equation. So I'm gonna move this one over. So I'm gonna get x equals 4y minus xy. You factor out a y, 4 minus x, x equals that, and then you divide by it, so you get y equals x over 4 minus x. And that's your inverse function.
All right, that makes sense.
Great. So I'll send you the notes out and the screen recording here shortly. Thanks again for scheduling, and see you next time.
Thank you, Matthew.
You're
Have a
welcome.
good
Have a
night.
good night. You too. Bye now.
Bye bye.